So the question is, how do you implement a LRU cache? So LRU cache is least recently used item. So it's a cache where suppose the elements that you put in is 1, 2, 2, 3, 1, and if the element and if the size of the cache is 1, 2, 3, 4, 5, and if you're trying to insert a new element which is say 3 or 4, since the size of this number or the size of the cache is now 5, you can't add the value to the cache. So hence you have to evict a value from this cache. So the value that you evict here has to be 2 because this is the least recently used value. So you take out 2 and you take out the value of the position here, and then you insert 4 into this cache. So yeah, that's least recently used cache. So now how do you implement it? So the basic way to do this is to use a hash map and a linked list. So when you hear the term hash map, right, the first thing that might come to your mind is you keep a key value pair. You store the key and the value within the hash map. So for key 1, you store say the value associated with the key 1, which might be a picture, right, within the hash map. Or for key 2, you put a different picture in the hash map. Now that's not the way we are solving this. So the hash map will actually hold pointers to a linked list. So it will be within this linked list that we store the values. So the linked list will have a key and a value. The key will be say 1 and the value will be the associated value associated with the key. So the hash map won't be storing the key values, but rather the hash map will be storing key. Okay. The hash map will be storing key and a pointer to the node. So for k plus 1, this will be the value that it points at, and this will be the key value pairs. So now the question is, so each time you want to insert an item, right, you add the item to the hash map, insert an item will have both the key and the value. So you insert the item into the key into the hash map, and you create a new node with a key value pair and put it in the linked list. So each time you insert something, you put it into the hash map and then make it point to this linked list and put it towards the end of the linked list. So now the question is, how do you make sure that it is each time you insert something into the linked list, right, it is actually affecting the least recently used item before inserting this item into the linked list. So the way to do that is there will be a get and a put to this data structure. So each time you do a get, what we will end up doing is you will so suppose you have to get the value k. You get the value k from the hash map, and this will point you at a linked list here. Say the key here is 5, and this is the linked list that the hash map value 5 pointed to, right? You take this linked list and you move it to the end of you take this node and move it to the end of the linked list. So you move 5 here. And what this property, where each time we do a get or a put, we insert it at the end of the linked list, gives us is that all the items that has been more recently used, it will occur towards the end of the linked list. So it gives us a form of temporal ordering where the items at the beginning will be the least recently used, and the items the items at the beginning will be the yeah, least recently used, and the items towards the end will be the most frequently used or the most recently used. So each time we insert an item, we insert or get or put an item, we move it towards the end of the linked list. And each time the capacity of the linked list or the capacity of the cache is is full, right? We evict an item from the beginning of the linked list. So we insert items at the end and we evict items from the beginning. An interesting thing to remember here is that we need to do this operation in order one. So both get and put has to be implemented in order one. So what happens in get, say, is suppose I'm trying to find the element 5, get the value for the element 5. So I see that this is at this location, and the easiest way to move it towards the end of the linked list would be to have a doubly linked list. Why does it have to be a doubly linked list? Uh, if it's a doubly linked list, what it gives us is that uh, yeah, it gives us the ability to remove an item in order one. So if it's a single linked list uh, and I need to remove this element, right, I will actually have to end up uh, having to find a pointer to this node so that I can update this next value from this node that I'm removing to this node. So that will introduce an order n complexity, because then I will have to iterate the entire linked list before I find this node. So just for faster removal, I will have to implement a doubly linked list and not a single linked list, and not a linked list in a single direction. So I'll move this element from here and then I insert it towards the end of the linked list. That is basically the idea behind LRU cache. It's pretty simple, but if you haven't seen the problem before, I don't know if I'll be able to solve it on the spot. But it's a neat little idea. Here we are using a linked list to maintain the temporal order, and that might be a more general pattern. Thank you.